Video number 262, the sum and difference identity for cosine. Now, I'm not going to prove why this works, but I'm going to briefly show, well, first of all, we need to understand this is definitely not true. You cannot just distribute the cosine for either the sum or the difference. In fact, the difference ends up actually being a sum, and the sum ends up being a difference when you're working with the cosine sum and difference identity. The reason this works, I'm not going to go through all of it, but here's why. Let's say you got a circle here. You've got your, let's say you got an angle here. Let's call this angle A, okay? Angle A. So actually, we're going to call this angle A here, okay? Big angle. Then we have an acute angle, angle B, okay? So we have big angle A and angle B. Then what we have is we could subtract B from A, and I'm going to grab a different colored pen here to do the subtraction. If we had, you know, if we took A minus B, that would be this angle here. Now, so this is A minus B. Okay. So, the reason this works is because we could call this point 1, 0. Okay? So you call that 1, 0. And you end up doing a distance formula on two different triangles. We're actually going to be able to say, and I'll put this in pencil, that this segment is equal to that segment. Okay? Because both of those angles that are formed could be considered A minus B. Alright? Each of them could be A minus B. So therefore, you end up actually doing a distance formula for this. Now this point here is what? You could call it cosine of this one would be cosine A minus B, comma, sine A minus B, okay? This is 1, 0. This point here is cosine A, comma, sine A. Okay, that's how you'd get that. And then this point here would be cosine B, sine B. So basically what you end up doing is a distance formula. You'll end up doing the distance between this point and this point. So you'll do y2 minus y1 quantity squared, x2 minus x1 quantity squared. You'll do y2 minus y1 quantity squared, x2 minus x1 quantity squared. And you'll end up setting those two equations equal to each other, and you will end up getting this first one will be the subtraction. And then actually the way you prove the second one is just simply by plugging in negative B. You could say that you could use cosine of A minus negative B, and then you plug negative B in for all of those, and you end up getting right there the sum of the cosine of the sum would be cosine A times cosine B minus sine A sine B. So anyway, this is why it works. Okay, so you can definitely check out a textbook. You can work out the distance formula there. You end up plugging in sine squared plus cosine squared equals 1. You'll end up making a couple trig identity substitutions. All right. Next, so let's go ahead and take a look. Here are the 4 problems we're going to work out in this video. Cosine 45, they ask us to find the exact value. For the second one, we're going to rewrite cosine 180 minus theta. For the third one, we have suppose that cosine S is negative 8/17 and sine T is negative 3/5. And they're both in the same quadrant, both S and T are. Find cosine S and S plus T, and then we're going to verify this last one here, secant. Okay, so let's do the first one, cosine 45. What we do here to get an exact solution, as you may have guessed it, is you're going to use your 60-30 right triangle and your 45-45. So we change 45 degrees into 60 minus, excuse me, we're going to change this one. We're going to do cosine 15. We're going to do cosine 15. Check that. We're going to do cosine 15 rather than redoing the video all over again. So here we are. We're going to do cosine 15. All right, here we are. Cosine 45 would actually be pretty boring. All you'd have to do is put down what? Root 2 over 2. So we're going to do cosine 15. Cosine 15. Cosine 15 would be, okay, then we would use 45 here. Actually, this part's right. Okay, now that we've confused everyone. All right, so we're going to do cosine 15, which is definitely not a traditional angle that we've done with either 45-45 or 30-60 right triangles. So you can take this cosine 15, rewrite it as 60 minus 45, and then we just use 60 and 45 into those places. We do cosine 60 times cosine 45 plus, you do the opposite of the minus, sine 60, sine 45. We make the substitutions from the 30-60 right triangle. You're all set. And the 45-45 right triangle. You multiply the numerators, multiply the denominators, you get root 2 plus root 6 all over 4. Let's move on to the next one. We have rewriting cosine 180 minus theta, the second one we're going to do. And here it is. We end up starting out with cosine 180 times cosine theta plus sine 180 times sine theta. And what's really cool is that cosine 180, of course, is negative. You're at the point negative 1 comma 0. So therefore, cosine is the x value. So negative 1 goes in for cosine 180. And then 0 goes in for sine 180. That's kind of nice because 0 times sine theta is just 0. So therefore, you're left with negative cosine theta. So now whenever you see this, you can just do negative cosine theta. It's pretty sweet. Next one. Suppose cosine s equals negative 8/17 and sine t equals negative 3/5. So, and then it says both s and t are in the same quadrant. What we're going to do is do this one at a time here. First thing we need to do, whenever you do problems like this, is to draw a diagram. And let's go ahead and take a look. Now, obviously, both cosine and sine are what? Negative. Therefore, they're both in quadrant 3. So I'm going to go ahead and draw. Now, I just go down the middle, but you don't necessarily need to do that. You can maybe figure out where you are, but this is going to be the reference angle theta. So then you go ahead and draw. Now I'm going to go ahead and, actually I'm going to draw a reference angle S. Let's call this one S. And they're telling us that what? Cosine S is negative 8/17. That means the hypotenuse is 17, and then 8 would be over here. Then therefore, using the Pythagorean theorem, that's 15. This is a Pythagorean triple. So you want to know your Pythagorean triples. It just works out so much better. We can also put t in here as well. And we have sine t is 3/5, hypotenuse is 5, opposite side's 3, therefore the adjacent side is 4. So then now you can just do all of the sine, cosine, or tangent of each one and make the substitutions, because that's what we're going to do. Cosine of the sum of s and t will be cosine s cosine t minus sine s sine t, and therefore you just make the substitutions. So therefore cosine s would be, well, they tell us that's negative 8/17. Here we actually had to use our reference triangle to get cosine t, 4/5, and we use a negative because we're in quadrant 3. Everything's going to be negative in quadrant 3 except for tangent, which we're definitely not dealing with tangent, so we're in good shape. Then you just plug in 15/17 and 3/5. You go ahead and multiply. 3 negatives gives you a minus, so you just subtract 32 and 45, get negative 13. Let's move on. Verify that secant of pi minus x equals negative secant x. And what we remember, hopefully, from previous videos, when we verify trig identities, you work with the more difficult side. So here we are. Work with the left side. We're going to change secant into 1 over cosine. There we are. And then, of course, because this is cosine and a subtraction, we can use this cosine subtraction identity. So cosine pi times cosine x plus sine pi sine x. And what's cool about this is you just use radians. Cosine of pi is the same thing as cosine 180, negative 1. Sine pi is the same thing as sine 180, which is 0. So therefore you end up with just simply 1 over negative cosine, which is definitely negative secant, which is what we have on the left side. So therefore, the left side equals the right side. So there you have it, ladies and gentlemen. We have just taken a look at the sum and difference identity when dealing with cosine.